Hi guys! In previous sessions, you have learned what is Android and how to create your very first project in Android Studio. Here, in this session, we will work upon views, layouts, and resources. I hope you remember how was the components we have learned in Android applications. There were activities, there were services, broadcast receivers, and notifications. But in this session, we will work upon the design part because Android application is incomplete without a proper appearance of the screen. So here we will cover the building blocks of views, view groups, view hierarchies, layouts, how we define them in XML and programmatically, and how we can put an event listeners on it. So what exactly a view is? Every Android application is made out of view. Views are a building blocks for user interface. We have text views, buttons, scroll bars, and images views. These views have some properties as well. So they are specified dimensions, colors, the positioning. They also may have focus, and they could be interactive, invisible, or visible. So these are all the subclasses of views. So in Android, we have three ways to define the views. We have graphical interface with the help of layout editor. We have XML files where we can define a bunch of XML codes. And third is the programmatically with the Java code. So here in this example, we are going to work out with layout editor. As you can see on the left, we have views. We can drag and drop to the basic component, and we can set the properties from the right side. And this is the basic representation of using layout editor. So from layout editor, you can restore its size, you can put a constraint and handle the constraint, and of course, resizable bars are there, the constraint handles are there, so you can make changes from the layout editor on the views. So here is another type of views which you can define in the XML. So here it represents a bunch of code written in XML. On the top, we start with the tag. Here the tag is a text view tag. And also I have told you that these views will have the properties. And here you can see the list of properties which is set for the text view. The layout width, layout height, and at the last you can see the text style, which is bold. So this is how you can set the properties. Here are further examples of how to set the properties in XML. And the first, we have specified the property name and the property value to the right. Here the property name is the Android layout width. That will set a width for that component according to the match parent value. Now the match parent value will take the width from the parent tag and put it there. Next example, we have a text, how we can represent a text. In the previous session, we have noticed how to refer the string files. This is how we have defined the string files, and now we are referencing it in a text. Next, we have an ID. This ID should be unique for every component so that in activity, we can specify specific action on this UI components. Here, it's the third type of defining the view in the Java code. So here, I have defined a text view. We have created a new text view object and specify it in the context. So this is specifying the context, the scope of that particular activity. Now we need to call that method setText for the object which we have created for text view, which will be passed the string inside it. Yes, so these are three ways to define the views. First, through layout editor, second through the XML, and third to the Java code. Now, you noticed in the previous slide that we have mentioned the context this. What is the context? Context defines the scope of a particular object inside it. It is a global information about an application environment. There are two ways to define the context. To get the context, we call get application context. And when we create the object, we call this to specify the scope of that particular object inside the activity or an application. We have hundreds of different types of views already defined in Android framework. But still, if you need some more views to be designed, you can go for custom views. You can define your own views by using view class and create a subclass of it. So now the next is view group and view hierarchy. View group acts as a parent to contain all the views inside it. It acts as a container for containing the views. View group is a base class for layouts and view components. It is of scroll view, linear layout, and recycler view. A scroll view is the one which contains the view components in a scrollable view. Now, the next is linear layout. For the linear layout, we arrange the views in a horizontal or vertical rows. We have recycler views for the scrollable list of views or the view groups. Now, this is a representation of a view hierarchy, how we define the view groups and views inside it. On the very top of it, view group acts as a parent, a root element, to contain either a view group or set of views. It also contains a view group. That means it's a nested linear layout could also be placed inside a linear layout. And of course, for without views, we cannot say that the linear layout is complete. So at the base, at the leaf, we always have views components. To understand this view hierarchy, we have this representation. On the top, we have a linear layout which acts as a view group. Inside it, we are defining 3 views. The first one is a button. Next, we have text view. And at the last, again, there is a button. So as you can see, on the top, we have view group, and inside it, there are views, which is defined. View hierarchy and the component tree. When we are working with the layout editor, we can see this component tree inside it to get the better understanding of this view hierarchy. This is how we can see. So there is a linear layout on top, and it has 3 views inside it, which is visible on the left. So there are best practices for view hierarchies. Arrangement of views hierarchy affects an application performance. So we have to take care while defining the view hierarchy. It should be minimal and as simple as possible. So it should not contain multiple nested linear layouts or multiple linear layouts inside it. It could be simple as possible. Use smallest number of code snippets and views inside it. Keep the hierarchy simple, and it should be neat also. Now, we are working with the layouts. To understand this layout, we have layout views. Layouts specify the view groups. As I have told you, like there are scroll views, linear layouts, recycler views. These are the subclasses of view group only. It can be in a grid layout, a table, a linear layout, or a relative layout. Here is an example. The first one represents the linear layout. If you can see, inside it, it has 3 view components. These are horizontally aligned to each other. Next, we have relative layout. As the name suggests, relative. That means all the UI components are related to each other, right? Next, we have third grid layout. Grids, we've give it a 2-dimensional layout and put the views inside it. And the table layout, it is specified like this. We can have rows and columns to be specified for each view component inside it. Here is a list of common layout classes which we generally use. There's a constraint layout. We put a specific constraint, and that will remain fixed when we are working with multiple devices. That means multiple devices will come along with multiple screen sizes. So here is a constraint layout which put the constraint on a view and make it constant throughout the devices. Next, we have linear layout. So linear layout, we can define the views either vertically or horizontally. Relative layout, that means the child views are relative to each other. We can place them relatively. Table layout, we can specify it in rows and column wise. Next, we have the frame layout. To show the views inside it, we use frame layout, like an example of image gallery. We swipe out right, left, and to see the views inside a frame. We have a grid view, which contains a 2-dimensional views in a grid format. Next, we have class hierarchy and layout hierarchy. What is this? When we talk about a class, that means we are talking about Java. And in Java, the hierarchy follows the concept of inheritance. We have a superclass, then we have a subclass created out of it. Take an example. A button is a subclass of a text view, and a text view is a subclass of a view component. And view is already defined as an object. So there is a superclass subclass relationship. And when we talk about the layout hierarchy, we have defined it like view group, and it has view components inside it. We have seen that how we create an XML earlier in previous slides. Now, it's a proper representation of doing it with XML code. On the very top, we have a parent tag, which is linear layout, and it has set of properties, which is layout width, layout height, and of course, we have to specify the orientation when we are using the linear layout. Inside linear layout, now we are going to define views. So we have edit text, buttons, text views inside it. And as we know that if we open a tag, we have to close it also. So after containing the views inside it, we close the tag in XML. This is how we represent it in a Java code. So for first, we define an object for the linear layout. Now, as I have told you, that we also have to set an orientation for the linear layout also. We set it like this way. Next, we now want a view object, that is a text view. So we create a text view object and specify the context for this particular activity. And we now need to set a text also on the text view. So this is how we define it. Next, we have to add this text view inside our linear layout. So with the help of add view method, we define this my text object and add it into the linear layout. At the end, we set content view, which is an activity code method, and put a linear layout inside it. So in the previous slide, we have seen how we can create an object for the linear layout and for the text view, and also how to add the text view inside that linear layout. Here, if I have to set a width and height of that particular view, this is how we do it. We call the layout param object. We create a layout param object. So first we specify the height. So first we specify the width, and next we specify the height. The match parent will take the width of the parent tag, and wrap content will take a height of according to that component size. And after this, we need to call a set layout param method for this.
Hello, welcome back. I'm Lalit Singh. So now you have seen views, layouts, how you deal with your UI components. Now we need to make them alive. Let alone putting a text view or button will not do any good for you if you design your application. You need to interact with them. So that's when event handling comes in. To understand it better, we are going to take a look at dad and daughter analogy. Let's see. Now let's just take a look at dad and daughter analogy to understand event handling even more better. So here we have a room and we have a shop. Now inside room, there's a daughter and there's a dad. Now daughter asks for a chocolate. For that request to complete, dad needs to present inside the room. So here, if I start comparing with my event handling, daughter is my event source who asks for chocolate. Dad is my event listener who listens to that event. And to complete that request, dad needs to go to the shop and buy one chocolate. So a shop here is considered to be event handler. So this scenario helps us to understand that this is how event handling goes. There is always an event, there is a listener to listen that event, and there will be a handler to handle that event. So now you have seen dad and daughter analogy, so you know now that you need three things to handle your events. One, the event source. Second, your event listener. Third, your event handler. So event source can be any view. It can be a button, it can be a text view, it can be a list view. So anything, or even can be a click event, even can be a long click event, or even can be when you are dragging something. So that's what the event is. And to listen for those events, you need listeners. And once an event has been listened by an event listener, then you need handlers to handle those methods. So a handler is basically a method which is defined inside your event listener. To handle your click events in Android, there are two ways, XML and Java. So when we are handling in XML, we can put that in an attribute named onClick. So a click event can be generated by any view. So you just have to put an attribute onClick and give the method name. Give a name. It can be any name. Do something, show toast, do message, and then that same method you have to put that in your Java file. So for example, let's say I have a event or I have a view and I have defined on click inside that. So show toast is the method I have defined in XML. Now I will go back to my Java, and inside that Java I will put show public void show toast, and the attribute will be a view object, and inside that I will put the code whatever I want to happen when that event or that view has been clicked. So here I can show a toast. Toast is an interactive dialog box which will be only used to notify the user. We will see in practical how exactly a toast looks like, but how exactly you define, you can see that toast, we create an object of toast, and we make a toast by providing 3 arguments, by putting a context object that is that would be defined inside your activity, this, and then putting the message, whatever the message you want to show. Here hello toast will be shown, and then the duration. A toast can be only shown in 2 ways, long and short. Long will show it for 3 to 4 seconds, short will show for 1 second, and at the end you have to show a toast by putting toast.show. Now there was how to handle in XML, but when we talk about Java, in Java you need to have a ID for that particular view. When we say ID, you need to know that which view you are handling. Let's say I want to handle a button. Now at that point of time, that button has been defined in your XML file, so you need to get the access of that button in your Java file. So that's when there's a method to do that known as find view by ID, and this method will give you the access of your that same button which you have defined in your XML with the same ID. Then once you get the access of that button, then you need to put your listener, then you need to attach your listener to this button. So here the listener name is set on click listener, and inside that listener we have a handler method known as public void on click, and this is where you will put the code to show something or do whatever you want when you want to click a button, when you want to click a view. This is where you put the functionality what you want when you click on a view. Now let's just talk about resources. How exactly we can define our resources in the REST folder. First of all, why do we need resources? Why do we need to define resources separately? If we can define them directly on our views, or if we can define directly them on our text views or any view. Well, it gives you it gives you a property of localization. You don't have to define that property again and again in coming views, incoming properties, or incoming wherever you want to use that resources again. So a resource can be a string, a resource can be a dimension, a resource can be image, audio file, text file. So that where exactly you will be putting the resources? You will be putting the resources inside your REST folder, and you can put them in any XML file with a tag resources. So res is the folder where you will be putting all your resources, and how you access your resources, especially if it is a layout one. So you will be accessing your layout resources by using r.layout. The name of your resource file which you have defined inside your res folder. As in my case, it happens to be activity_main. So you must have seen this kind of example in your you must have seen this kind of coding in your examples also. We do set content view r.layout. Your activity_main. So what exactly is that? I'm accessing my resource file from my REST folder, and whatever you do inside your REST folder, it gets saved in your r.java file. Next, view. In the similar fashion, if you want to access any view which you have defined in your REST folder or inside your UI or layout file, and you want to get the access of that view inside your Java file, that's when you use find view by ID, and again you make use of r.id. Whatever the ID you have given for that particular view. And if you want to use a string in Java, you will use r.string.title. You will use the dot operator in Java. But if you want to use that same string in your XML, that's where you will use the @ annotation. That's where you will use @. @ will directly refer to your r.java file, and from there you will follow that which class you want to access, like string slash whatever the ID name you have given or whatever the name you have given to that particular resource. When we talk about measurements, when you want to define any view size or for any image size, so that's when you will be using DP, known as device independent pixels. Now, whenever you are defining the size of your font or text, that's when you will be using SP, that is scale independent pixels. Now, do not make use of all these units, pixels, or points. These are not allowed in your Android. To learn more about the views, you can follow these links, or about layouts, you can follow developer.android.com. And about if you want more information about resources and other stuff, we have links here to go about it. Next, we will see the actual implementation of views, event handling in the practical.